Okay, mic on. Can everyone hear me? All right, awesome. Thank you all for being here. It is, I think, 1:01, so we'll get started since we have intro stuff to do anyhow, so by the time other people get here, if they're coming, we should, there's plenty of time for them. All right, so you're in the right room if you came here to learn about working with Taproot Assets on Lightning. That's what we're going to be discussing today. This is actually the third time I think I've done this workshop at TABConf, and the first time was when Taproot Assets was new. Second time was when we had on-chain functionality, and now this time we have Lightning functionality. So that's what we're going to be focusing on today. I'm going to leave this slide up here if you want to follow along with the demo that we're going to do today, or if you're interested in the resources that are linked to, you definitely want to scan this. Please let me know if anyone runs across any permissions issues. How's the screen? That looks a little shaky. Is it all right for y'all? Is it okay? All right, cool. All right, so I'll let everyone scan that. We're talking about Taproot Assets on Lightning today. This is a big one. We're scheduled for 2 hours. The first half, roughly, we'll just see how it goes. The first half, we're just going to be talking about the theory behind how Taproot Assets can be added to Lightning channels and exchanged on the Lightning network, and the theory about how all of that works, edge nodes, the RFQ process, all of that. And then roughly for the second half, we will actually play with it. So if you want to play along with that, you can download Polar. That's what we'll be using. So I'll start going through my slides here and do intros, and then we'll go into the details of, you want Docker and Polar on your machine if you want to follow along with the demo. All right, so hi, I am Hannah Rosenberg. I am a developer advocate at Lightning Labs, which means it's my job to help you make use of any of this tech. If you're interested in building with it, it's my job to help you, so come ask me lots and lots of questions about it. I've been in the Bitcoin world a long time. If you're curious about my resume, a lot of it's up there on LinkedIn. Of course, I'm on Twitter, and you can find me on Nostr as well. All right, so I've made some assumptions about all of you that, the people that have showed up to a technical workshop at TABConf, I'm assuming are kind of technical, so I've made some assumptions here. I'm assuming you're a tech-savvy Bitcoiner. That means you know what a UTXO is and you know what an HTLC is, right? So I'm kind of assuming that level of knowledge there. And that you're also a little bit familiar with the Taproot Assets protocol, right? So today I'm not really planning on doing like an in-depth, explanation of how Taproot Assets works, because I want to focus more on the Lightning stuff. So we'll do a very brief review and then really focus in on the Lightning aspect of it. All right, so if you want to participate in the second half, the demo where we actually play with this stuff, then you'll definitely want to put Docker on your computer. In the slide deck, this is a new machine for me, so I just got this one recently and put Ubuntu on it, so I had to install Docker and Polar and all that stuff, and I just copy and pasted every command that I use to get it set up on my machine, so hopefully that's helpful for you if you're installing Docker. This is a Ubuntu machine, so all the instructions are Linux-based. All right, and lightningpolar.com is where you go to download Polar. And again, lots of info in the slide deck, and we'll come back to that in the second half. All right, so I have a whole plan, obviously, for what we're going to go over today, but you all bought tickets and showed up, so I will endeavor to give you whatever information you're looking for. So does anyone have anything specific they're hoping to learn about Taproot Assets on Lightning today? No? Cool. Something? What would you like to learn? So like a setup, like how to set up a Taproot Assets node and all that? Cool. Okay, yeah, that's something I definitely think we will be covering. And yes, yeah. Yes. Okay, so yeah, what we could do with this in the future? Yeah. I think we'll cover a bit of that as well, too. Yep. Okay, sending coins to where? Global, oh, so to developers in sort of the global marketplace. Yeah, awesome. Yeah, and that is like a very interesting use case, right? So, engaging in commerce with people in different parts all around the world. And that's more a use case, but we can touch on some of the use cases when we talk about setting this stuff up. Yeah.
Well, I was going to say, if anyone wants their question recorded, here's a mic. I don't know if that helps, but
Okay, so we are recording.
I don't know if we have a mic runner in here, but.
Okay, yeah, I will repeat it. If you want to be on the recording, you can go up there. If you don't, just yell and I'll repeat it. Yeah. Stablecoin viability. We're absolutely going to be talking about stablecoins from a technical perspective, right? So I'm kind of not going to spend a lot of time on like the business stuff, even though that stuff, or the use cases, or, but that stuff's fascinating, but yeah, it's more technical, yeah. Determining decimal display value. Yes, we're totally going to cover that. Gotcha. So that's a question about generating invoices in the RFQ process, and we're definitely going to dive into the RFQ process. Also, as we do this, it gets, I think, really boring for everyone, including me, if I'm just shouting at y'all, so please let's do this very interactively and have a conversation and ask lots of questions as we go. And we also have a number of people from Lightning Labs here today too, so there we go, there they are. And there he is back there, yeah. Cool, awesome. So let's talk about what we'll cover. Again, we did this a little bit, but the goal is my goal, right, is for you to walk out of here going like, oh, I think I understand how Taproot Assets can work on the Lightning Network. And if I want to build something with this, I know what tools to use and I know how to use them, and sort of get you well prepared for working with this if you want to. So understanding the protocol, we're going to talk about LitD. We're going to use that via Polar. We're going to talk about RFQ settings, very important topic. And we're going to talk about opening channels, sending assets on Lightning. And again, please ask many, many questions. Awesome. And of course, live demos always go exactly as planned. We know that, so please bear with me if there are any issues as we get through this. All right, I think we've already gone through this. We're just going to do a very, very quick sort of review, and then we're really going to focus in on the Lightning stuff. Cool. And in part 2, again, we're going to talk about edge nodes, the RFQ process, all of that. And of course, if you want to participate, you need a computer with Docker and Polar. All right. So, any questions before we dive into the theory of Taproot Assets on Lightning? No? Cool. All right, so we're going to do a very, very fast review. I think a lot of you have been to previous workshops we've done here, right? So, a couple people? Yep, there, yep. And so I'm assuming you all have a rough understanding already of how Taproot Assets works, but we'll do a quick review just to, for anyone who isn't already familiar, or just to get it fresh in your head again, even if you are already a little bit familiar. This is a picture of what is already a very simplified set of Merkle trees, the type of data structure that's used in Taproot Assets. But it's a, fairly technically correct, just simplified picture there. Of course, Taproot Assets makes use of the Taproot upgrade to Bitcoin. It uses specifically TABScript and TABTweak. And this data structure, which we're calling a Merkle sum sparse Merkle tree, that is what it's called. And it is, of course, very complicated and very interesting, but the summary here is that all this asset data is stored in this sort of set of Merkle trees, right? So we see at the top here, we have, standard Taproot, TABScript sort of stuff going on. Then in this leaf is where we start our Taproot asset specific stuff. We kind of think of this as having 2 layers, right? First, we have this sort of group layer, right, which is important if you're going to be minting assets like a stable coin, that there might be rounds or tranches of these assets that you're going to be minting that you want to be sort of fungible with one another. That's where this layer here is very important. And then we have this bottom layer here, which is actually has the details of a specific asset. All the way at this leaf at the bottom, here are some details on a specific asset. So that's just a refresher on what this data structure looks like. And then, do I have a slide? I think, hold on, yep. And then we'll talk a little bit about when we mint an asset, how this actually gets sort of embedded in or committed to, however you want to think about it, the Bitcoin blockchain, right? This gets recorded on the Bitcoin blockchain. And you can think about it, sometimes it's helpful to think about it in the sense that Taproot assets live sort of in UTXOs, right? They get kind of embedded in a UTXO. So this is what a Bitcoin transaction looks like in my head, right? We have inputs, and then in the middle, we have, you know, this unlocking and relocking that happens, all this validation that happens on Bitcoin nodes. And then you have these outputs, right, which come out of this transaction. So if we imagine that Alice is minting some Alice bucks, which is going to be a stable coin, right? She, on her Taproot Assets node, she would create, you know, that Merkle tree structure, all of this data. Then she would summarize this all the way up till we get sort of this root hash, right? And then here again, at the top of this, sort of the head of this tap script Merkle tree, we get another root hash. And then if we all remember tap tweak, right, we know we can take that sort of root hash and, you know, with fancy math, sort of mush it together into an address, right? And that's how we embed all of this data into a UTXO. And then that lives in Bitcoin on the Bitcoin blockchain in a matter of speaking, right? So some of the benefits of doing this in this particular fashion is that when you have, you mint Taproot assets, and this process happens on the Bitcoin blockchain, it's happening in a very standard looking Taproot transaction, right? And this is indistinguishable from a regular Taproot transaction, right? So someone just watching the blockchain, unless you specifically tell them or there's someone you're transacting with, they're gonna have no way of knowing that there's a whole bunch of Alice coin that just got minted in that transaction, right? And this reduces blockchain bloat, right? There are many different ways to add data to the Bitcoin blockchain. This one is quite nice because it really reduces bloat. This is a very standard, simple Taproot transaction, right? And all that data is just sort of hidden in there. It's quite cool. All right, of course, it's entirely opt-in. Bitcoin Core knows nothing about this and does not ever need to know anything about this. We all use this if and when we want to. And yep, there's no need for a Bitcoin node to run Taproot assets. All right, so any questions? That was a super duper brief overview of Taproot assets. Obviously, there's quite a lot going on. Does anyone have any questions about the basics of how Taproot assets are minted, added to UTXOs before we move along? No? No? Communicating, okay, so it's like, what is a Taproot asset node doing? When you talk about that data, I think you mean like if Alice mints a bunch of Alice coin, how does someone else make use of it or know anything about it? So there's this concept of a universe where Alice can run her own universe, or perhaps there's a public universe, and then she can share sort of the copy of all those Merkle trees and some proofs that shows that she embedded, you know, those assets in this particular, using it happened in this particular transaction, right? And so she can provide proof to Bob that those assets are there and here's all the data about them. And that you do this using a universe, you know, which is just basically a data store server, right? She can run her own, she can send this to a public one. Is that the answer you're looking for? Awesome, cool. And was there a question back here? Okay, so the question is like, how are we maintaining this data in the system, right? So basically, if you run a node, right, if you're running a Taproot Assets node and you're minting or you're transacting, like you hold on to that data, right? That data lives on your node, or it can live in a public universe, right, a public server, or with whomever else you choose to send it to. But the blockchain, right, serves as proof, right? So you can have proof, time stamping when this stuff happened, et cetera. But the specific data about your asset, right, it's like your job to hold on to. So the person running that Taproot Assets node, they have to hold on to that data.
Server to prove anything. A node doesn't need to access a server to prove anything. You retain, sovereign state that then you can produce proofs on. You can create transactions without any other third party.
Yeah, cool. All right, any other questions? One back here?
Might be getting ahead a bit. I know that you wanted to talk about Taproot channel operations.
Yeah.
Is that where we're going to get into the transactional operations, sending an asset from one person to the other?
Okay, so do you want to do a very briefly sort of an on-chain transfer before we get into the Lightning stuff? Like cover that?
Yeah.
Okay, cool. All right, I think I have some slides that show that. You can do that very briefly. No, that's not quite what I'm looking for. Asset split. This one was made for a bit of a different background, but can we see that roughly? Okay, all right. So the idea is if you're doing a transfer, so Alice minted some Alice coin, and this happens on chain, right? She creates all this data on her node and then she commits to it on chain. In that Taproot transaction. And here in this example, Alice has minted 10 Alice bucks, right? And then she wants to send 5 of them to Bob, right? So that is another on-chain transaction. And essentially, if you remember that graph where we had inputs and outputs, right? And basically, we can imagine that there's an input, which is the UTXO, where that, Alice bucks was originally minted. It goes into that transaction. And in that transaction are 2... We've got music, fabulous. In that transaction are 2 outputs. And so you can kind of take, imagine in that output that goes back to Alice, there's an updated Merkle tree. Obviously, this is a very, very simplified and stylized Merkle tree, but she gets an output, a UTXO that has 5 Alice bucks, and Bob gets a UTXO that has 5 Alice bucks. So that's called a split, right? That's sort of the simple sort of transaction, and that, of course, this happens in on-chain Taproot transaction. Cool. All right. Any other sort of Taproot Assets on-chain questions before we attempt to dive into Lightning? We're going to cover LitD before we talk about Lightning, but any other on-chain Taproot Assets questions?
Can this use to create a wrap Ethereum, just lock Ethereum inside a Bitcoin Taproot asset?
One more time, please.
Like reverse, can we lock some, when you say mint some coin, right?
Yeah.
Can we really lock some other kinds of assets inside the Taproot assets? For example, like Ethereum.
No, so this is happening on the Bitcoin blockchain, right? So in that transaction, there's definitely going to be Satoshis, right? So because Bitcoin, Bitcoin Deep, Bitcoin Core just knows about Satoshis, right? So there's definitely going to be Satoshis in that transaction, and then there's going to be Taproot assets, and you could have all kinds of different Taproot assets, right? You could do sort of a batch mint, so you could make that collection of Merkle trees bigger, right, with more assets in them. But these are all going to be assets, of the variety Taproot assets. So if you wanted to do an asset, you could do a Taproot asset that is representative of something from another system, but it would be using this protocol. Cool. All right. We talked about all of this. Now let's talk a bit about, there was a guy that had the question about setting this stuff up. Let's talk a bit about what tools we can use to work with this before we dive into the Lightning stuff. Does everyone know what LitD is, Lightning Terminal? We're all familiar with that? Cool. The Lightning Terminal, Damon, thank you for asking. It is, so if you have Previously, right, the last couple of workshops I did, the sort of tech stack that I was demoing was having a Bitcoin backend. I like Bitcoin D, right? So we're using Bitcoin D. Then we're using LND, the Lightning Network daemon, and then we're using Taproot Assets on top of that. All right, so now I'm demoing a little bit of a different setup where I'm just using terminal so Bitcoin and then LitD, Lightning Terminal on top of that. And LitD is just, this bundle, right? So it has, we like to run it in integrated mode, which means that it's, one program which is running LND, Taproot Assets, and then if you like, Loop Pool or Faraday as well, right? So that's this bundle. And LitD here is helping us with the communication between, our Lightning node and the Taproot Assets node. Right, so we bundle this all together, and it all works pretty smoothly together. You'll see when we work with Polar, we'll be running terminal nodes, right, LitD nodes, and then you can see too in some of I have some videos in here where you can see me working on the command line with LitD CLI commands. Cool. So any questions about this bundle, working with it this way? No? Awesome. Cool. All right. So now we're going to talk about a couple of new things that I just want to mention about the latest version of Taproot Assets, some really cool stuff before we spend all our time fixating on Lightning stuff. So PSBT swaps. Is anyone familiar? Everyone knows what PSBT is, right? Partially signed Bitcoin transactions. We're all fairly familiar with that. All right, so Taproot Assets users and developers can automatically swap assets for Bitcoin or other Taproot assets via partially signed Bitcoin transactions. I will once again commit the presentation crime of reading directly off my slides before I show you a pretty picture. All right, we can trade non-interactively in a chain-efficient manner and without requiring trusted counterparties or a centralized coordinator. Sounds awesome. Let me show you a cool picture. This is what PSBT swaps look like in my head, and I'll give you a brief example. Let's imagine that Alice has minted some of her Alice bucks, and they've done very well. They are very popular, but she wants some Satoshis. And we have Bob in this scenario. Bob is someone who has some Satoshis and wants to get his hands on some Alice bucks because they're just very trendy at the moment, right? So what Alice can do, roughly, is create a Bitcoin transaction, right, where she adds some input, right, and this input is, some of the Alice bucks that she's minted, and then there's an output which sends her some Satoshis, right, and she can create this, partial Bitcoin transaction and add her appropriate signatures to it, and then we can imagine there's some service somewhere or some forum where she can just post this PSBT, right? And then, she goes to bed, she creates this, pushes a button, shares it. She goes to sleep for the night. In a different time zone, Bob wakes up, says, I really want some Alice bucks, right? He sees this, he comes along. He adds an input to that transaction that adds some Satoshis in, and he adds an output to that transaction, which sends him those Alice bucks. He adds his signature to it in the appropriate places. The puzzle pieces come together. This is now a complete Bitcoin transaction. He broadcasts it on the Bitcoin blockchain. Alice wakes up in her morning and realizes, hey, she sold her Alice bucks and she's got some Satoshis. So pretty cool, huh? Any questions about that? Yeah. Good question. So definitely one-to-one. I think, so the question is, can we do this just one-to-one, so Alice exchanging with Bob, or could we do this where Alice sells Alice bucks to Bob and Charlie and Diana all at the same time? All right. JHV, right there?
Okay.
So it's theoretically possible. Is it theoretically possible to do that? All right.
If it's something like what was just described with an auction, you may post this in public and only, like multiple people maybe, I don't know, bidding or involved and only one person completes this. You could maybe do something more complicated where you're selling multiple things at the same time and multiple people end up buying them in one transaction. I haven't really thought about that much, so like maybe, probably, it's fine.
JHB,
Probably.
would it be accurate to say that you could create a trustless L1 swap, but you would have some interactivity requirements to basically prime, the swap and everything?
Yes. Yeah. And then, yeah, after this trade is done, like let's say you came along and you've paid for this swap to complete, you still need to send some data afterwards so that you have like the full history of this asset or like full proof so you could send it on to someone else after.
Yeah, so essentially what you're doing is using the SIG hashes and constructing, this Merkle tree to say, hey, there ought to be something here. And if and only if it is there, will this transaction go through successfully? So you can, can achieve it in a atomic, trustless way.
Cool. All right. Awesome. Okay, so we're going to talk about one more possibility, and that is multi-sig support. So it's a question we get a lot. Obviously security is very important. If someone's minting assets of various different kinds, are going to be holding on to these. Like, how can we secure these? These are things that are now possible with the new version of Taproot Assets. Not all of them have nice API calls at the moment, but these are all possibilities, things that you can do. So we're going to talk about here, I'll just list this bullet points, the different layers and levels at which this is possible, but then I'm going to show you a pretty picture because I think that really helps a lot to understand it. All right, here's the pretty picture, right? So we're again looking at this, multi-level Merkle tree, and we're looking at the different places in which it's possible to add multi-sig. So obviously at the internal key here and this Taproot stuff, we can do musig too. All right, then we can look here in sort of the Taproot script level. In here we can do musig2 or old school K of M. We can also do that when we get to this group key level. So down here we can do musig2 or K of M, and then all the way down here at the asset level, the asset key level, we can do musig2 or K of M. So I just want to note that, all very important stuff for people that are looking to secure Taproot assets. Cool. So any questions, any more questions on these possibilities before finally we dive into the Lightning specifics? Yeah? All right, cool. All right, so like I said, the goal is for everyone who's here to walk out of this room going, I understand how Taproot assets are added to Lightning channels. So we have lots of pretty pictures. We're going to look at this from about 3 different angles, so hopefully that will get the job done for everyone. All right. So again, let's go back to this picture, right? This is how Taproot assets are minted or transferred on chain, right? So we have all this huge data structure right here, all these Merkle trees, and we can sum that all up and then use tap tweak to add this into a UTXO, right? So does this kind of everyone have that visualization where we have these Merkle trees, we get that root hash, and then there we go, question back here.
Where does the Taproot UTXO, biggest question, where does the Taproot UTXO live? Is that in the Bitcoin blockchain, or is it an external data storage?
Okay, so kind of both. Hold on, let me move this thing.
Is the question the Taproot asset output or like the Bitcoin Taproot?
I know the minting occurs inside the Bitcoin blockchain, but then subsequent transactions
right.
Beyond minting.
Yeah, let me sort of cover that a bit. So the idea is if you have a Taproot asset node and you want to mint some asset there, your node is going to create this data structure that has these Merkle trees, right? Then you're going to get all the way down to the sort of TapScript level root hash that summarizes all of that different data. You're going to use tap tweak to then sort of embed that or commit to that, however you want to conceptualize it, in the Bitcoin blockchain, right? So that data is all summarized in a Taproot transaction on the Bitcoin blockchain. Now, the full set of that data with all those different Merkle trees, that lives on your Taproot asset node or whatever node you choose to share it with. If you want to send it to a public universe, then they have a copy of that as well. If you want to then transfer this to Bob, then you would have to send Bob this data plus appropriate proofs to prove to Bob that you did indeed mint these assets and you didn't inflate them and all of this other sort of stuff. So, does that help?
Yeah, thank you.
All right, awesome. Cool. Question here.
You need to store the new information to the node, or the delta will just live inside the Bitcoin blockchain?
So the question is, right, when you then do an on-chain transfer, right, what data needs to be stored where, right? Okay, so your node would, so on the blockchain, right, we would go through this process where I just showed that slide where we did the split transaction, right? You would come up with a new Merkle tree, right, the new set of Merkle trees, which represents sort of your new state. And then again, if you're sending something to Bob, so you would keep a track of the original, like you would have the data on the original set of Merkle trees, the new state, and proofs that showed that you made that transaction. And this again would be summarized in the Bitcoin blockchain. Bob would have proofs, right, that he can use to validate for himself that that minting occurred when you said it did and the appropriate amount of assets were sent to him. Does that make sense? Awesome. Cool. All right. So now we have an idea of what's happening when we're minting assets, when we're committing to them on the Bitcoin blockchain, and when we're exchanging them. Now, how do we add this to a Lightning transaction? All right, so we can imagine that Alice has minted her Alice bucks. We can see that now we're looking at this scenario. So we can say here, this slide, this is when Alice is doing her minting, right? And then we have that UTX there where these Alice bucks are currently living. Now, she wants to take those Alice bucks and use them to open a Taproot Assets enabled Lightning channel with Bob, right? So Alice is going to do the sort of channel setup, right? She's going to open that channel to Bob. And this is a little bit what that looks like, sort of conceptually what that looks like. So Alice has those Alice bucks living there in that input that she's going to use on this transaction, right? And because Alice is opening the channel, she's going to do the funding. So there are definitely Satoshis that are going to go into that output. The output, which now is the Lightning channel, right? So there are Satoshis in there, of course, because we need to do on-chain operations in Lightning channels, and because Bitcoin D doesn't care about Taproot assets, it cares about Satoshis, right? So we have Satoshis in that channel, but we've essentially done like that split transaction that we were just talking about. So maybe Alice doesn't want to put all her Alice bucks into this channel. She wants to put half of them, or whatever the case may be, right? So she creates this UTXO, right, or this output that she does this, usual channel setup coordinating with Bob, right? So they have all the appropriately signed transactions, and she then puts these assets in this channel. A very important thing to note here is that this is, of course, a Taproot channel on Lightning, right? So LND has had for, was it maybe a year now? It's been a minute, right? We've had Taproot channels that you can set up using LND. So this is, of course, a Taproot channel because we have to make use of Taproot in order to use Taproot assets. But Alice opens this channel, and in that channel, so she's using a UTXO, right? She's using, it is an input, a UTXO that has Taproot assets in it, and then creating that output, which is the Lightning channel with Bob that has both Satoshis and that embedded in there, that Merkle tree data structure that holds the assets. Cool. So we're going to look at this from a couple of different angles. I have lots and lots more pretty pictures for us to look at. All right, hold on. Cool. All right, so these are unannounced Taproot channels, right? Because currently Taproot channels are not gossiped, right? So these are sort of unannounced Taproot channels that this happens in. We again are using TapTweak, just like we do with all of these transactions. And of course, these are just as before, Merkle, sum, sparse Merkle trees, right? That's the data structure. And again, assets, we can think of it as they live in these UTXOs, and these UTXOs that we use to open Lightning channels. All right, so let's look here at a visualization of a simple Lightning channel, right, between Alice and Bob here. Alice opens the channel and she has some Bitcoin in it. This is what the initial state looks like. Alice sends some money to Bob, right? Alice owes Bob some money. She sends him some money. This is what the state of the channel might look like after a while. And we're all fairly familiar with this, right? So we understand that these are sort of potential settlement transactions. It's what's going on here, right? These, HTLCs and whatnot going back and forth. And we have these signed transactions that when the channel is in this state, if either party wants to close out of the channel, this is the balance they're going to be getting, right? They can settle this on chain. All right. Now, the similar sort of thing, right? Same sort of things happening with an asset channel. But we can visualize this as sort of the initial state. Note that I put a Bitcoin symbol on there and some dollar symbols. We can imagine that Alice Bucks is maybe a US dollar stable coin. And I'm gonna drop that Bitcoin symbol off there in coming examples just for simplicity, but I add it here, again, to note that we have Satoshis in all of these channels, right? We need Satoshis, we need this for on-chain transactions, and because Bitcoin cares about Satoshis, right? So we definitely have to have that in there. And then after a while, right, so Alice opens this channel with Bob. It has Alice Bucks in there. Alice sends Bob some Alice Bucks. This is the updated state of the channel. So fairly simple, but we need to keep in mind that what that means is that they have constructed a transaction between them where if they settled, Bob would be getting a UTXO that has Alice Bucks embedded in it. Well, all right. So, does everyone kind of understand that? No, okay, so the question there is, how does Bob, if he had to close, when the channel is in this state and Bob wants to close, how does he make use of those Alice Bucks, because how can he pay the appropriate fees and get that settled, right? And so all of the usual logic that's happening in a Lightning channel is still happening in this scenario. And so while it's not, maybe I need to update the slide and put another B on the other side over there so we can note that Bob also has some Satoshis and the appropriate amount of Satoshis that he needs to be able to do his on-chain transactions. So LND, right, is still doing its usual stuff where it's making sure that there are appropriate amounts of Satoshis to handle fees and whatnot. Question here.
Yeah, so to be clear, so Bob in this case, Alice and Bob both have to have the full tree. They both have to be like full nodes in the sense that they both have the tree. And then for each payment, does the tree get updated each time?
So basically, yes. And thank you for providing me a nice segue into my next picture here. Right? So essentially, like every time you do sort of an update, to a Lightning channel, you're creating a new transaction that can be your settlement transaction that you can take back on chain, right? So this is like so this graphic, you'll notice, looks just like the split transaction, the on-chain split transaction graphic we just looked at. It actually is. I just changed some of the colors to make it a little prettier, right? But it's the same graphic, right? And the idea is that you're creating a potential split transaction every time you're updating that Lightning channel, right? So Alice, let's say she started out with 1,000 Alice Bucks in that channel when she opened it, so all the Alice Bucks are on her side. After a while, she has sent 100 of those Alice bucks over to Bob. And so that means there is a potential like settlement transaction in that channel that Bob can use at any time, where there is a UTXO that has that Merkle tree structure in it that gives him 100 Alice coins. All right.
So Hannah, like in the 2 trees on the right here, one of those is Alice and one of those is Bob?
Correct. So this is the initial state here where Alice has all of the Alice coin. And then this over here is sort of, it's like that's our transaction there. We've created a potential, settlement transaction where this 900, that is Alice's, that's the Merkle tree data structure that is in Alice's UTXO. And that 100, that is the Merkle tree structure that is in Bob's UTXO. Cool. Awesome. All right, and then here also I took that same graphic and mushed it back into this graphic, if that helps you. So there we have that initial state, and then we can see this is a potential settlement transaction that Alice and Bob have signed, where Alice gets 900 there and Bob gets the 100. That's probably a little bit too small to read, but you can get an idea of what's going on there. Cool. So, have I succeeded in helping people understand how Taproot assets work in Lightning channels a little bit? Yeah?
Two questions from folks.
Yeah. Did I hear someone have a question?
Oh.
There? Okay.
Yeah, so for regarding like a revoke transaction, like let's say Alice and Bob have 10 transactions. Does that mean there's 10 like Merkle trees that need to be stored?
So it works like the same way you would conceptualize a normal Lightning transaction, right? We have all these old potential settlement transactions that have old data. Like maybe an old one is this exact structure, except Alice has 950 and Bob only has 50, right? And then we have the same penalty mechanisms that work in Lightning now, so Bob doesn't want to broadcast, or Alice doesn't want to broadcast that old one. But essentially, yeah, you would have, okay, this is the current state. Wait, then we update it and we create a new potential settlement transaction, and the balances in those Merkle trees are going to change on each one. Yeah. Cool. Any other questions? One here?
If the channels are unannounced, how do other nodes on the network discover where they can get Taproot assets?
Y'all are, oh, hold on, we have to talk about this in a minute. Okay, so give me like 5 more minutes and we have a pretty video we can show you that explains how that works, right? We're gonna talk about what sort of, what this looks like on the broader Lightning network. So we're gonna focus a little bit more still on, now we're gonna talk about sort of multi-hop payments rather than just the simple, and then we'll talk about how this looks in the broader Lightning network. So, we'll first introduce this concept of an edge node, and this is a node that might facilitate some exchange on the Lightning network. So we can then imagine that we have Alice, and we have Bob, and we have Charlie, right? And so now in this scenario, we know that Alice has minted her US dollar stablecoin, which is Alice bucks, and now we're gonna imagine that Bob has decided to be an edge node, right? He's going to run this edge node functionality here, and he is going to allow Alice to, or anyone holding Alice bucks, to then interact with the broader Lightning network and interact with Charlie here, right?
Is an edge node a separate piece of software, or?
Great question. No, an edge node is basically a configuration change you make in your litd config file, right? So basically anyone running a litd node can just go in and make some config changes, add a little price oracle, which we'll talk about soon as well, and ta-da, you're an edge node, right? So does that make an edge node an exchanger? So I am not going to come anywhere near that from a legal perspective, but from a technical perspective, they are like engaging in, they're not really exchanging. They're like, it's from a technical perspective, you can see what Bob's doing is updating his balances in some channels and reducing his balance in other channels and vice versa, right? So from a technical perspective, he is moving liquidity around on the network, right? So we call that whatever you like. Yeah. Cool. All right, so let's imagine this scenario. Alice has some Alice bucks. She has this big channel with Bob. Bob is functioning as an edge node. She wants to interact with Charlie. So Alice owes Charlie some money. Charlie sends her a regular Bolt 11 invoice, right? Pretty standard. Alice doesn't want to pay that with Satoshis. Perhaps she doesn't have the Satoshis to pay that, or perhaps she just wants to make use of her Alice bucks, right? So what she does is she sends some Alice bucks along to Bob, and then Bob sends some Satoshis along to Charlie, right? Fairly simple graphic. Obviously, there's a lot going on with Bob's node because he's acting as the edge node, and we're going to dive into that a bit more. So let me see. Oh, here we go. Okay, hold on. There, we're going to show you the picture where we look at the broader Lightning Network and talk a bit about that. And we're definitely going to get a bit more into edge node functionality and what exactly Bob is doing there and how that transaction is going back and forth. All right. Cool. So we've introduced the concept of an edge node. Now let's go look at a graphic that sort of shows this on the broader Lightning Network to get some visualization there, and then we'll dive more into edge node stuff. All right, so here we're gonna imagine we have Alice, Bob, but maybe Charlie or Diana or something is way out on the edge of that network. All right, so we're gonna do a little bit more of a complicated scenario this time. We're gonna start over here on this end. That's Alice with her Alice Bucks USD-based stablecoin channel with Bob. Bob is acting as the edge node in this scenario. So here's Bob, he's our edge node. If we were just sending to Charlie, maybe we'll say this is Charlie, then this exchange would look just like that graphic we saw earlier. But now let's imagine instead Alice is interacting with, I have no idea. Zane. Okay.
That's what we call them, the eye tests.
Yep. So Alice is now wanting to interact with Zane, who is all the way over on the other edge of the network, right? And we call this sort of the edge of the network, again, in part because these are these unannounced channels, right? So Zane has a connection to another edge node, which is running right here. Right, so this is an edge node as well. And in this example, I made this blue. Apologies to anyone who's colorblind in the room. This one's blue, right? This one's green. So the idea is that we're imagining that Zane has a Euro stablecoin channel, right, on the Lightning Network. And so what Alice can do is she can use her US dollar stablecoin to send a transaction out on the Lightning Network. This edge node is going to do some changing, right? So it's going to accept US dollars stablecoin and send out Satoshis out on the broader network. All of these nodes in the middle here don't have to know anything at all about Taproot Assets, right? Maybe they're all Taproot Assets nodes, maybe none of them are, right? It doesn't matter. We're using regular Satoshi-based HTLCs all throughout the center of the network there to conceptualize it that way until we get over to this edge node right here. And then this edge node is again accepting Satoshis, but sending Euro stablecoin to Zane, right? So we can kind of see that it is sort of from how we're conceptualizing it here. This is happening out on the edges of the network. The center of the network knows nothing about Taproot Assets, does not ever need to know anything about Taproot Assets. They're just like, yay, I'm getting some liquidity through my routing node, right? I'm getting some activity through my routing node. And Alice sends a US dollar stablecoin and Zane receives a euro stablecoin. So talking about use cases and international exchange here earlier, and I think this structure certainly enables quite a lot of that. So I'll pause here for a second and see if anyone has any questions on this. Looks like we got one there.
In the case of slippage concerns, it looks like there's an enforced one hop on the original Taproot asset, then you move Satoshis to the last hop where the edge node changes it to that final currency,
Right.
that final Taproot asset.
Yeah.
Is there an enforceable path in the future where the Satoshi path is strictly that Taproot asset the entire way to avoid that slippage concern?
So what do you mean by slippage? Are you talking
Like,
about?
yeah, it might be helpful to talk about the RFQ process. So,
Okay, so we're talking
yeah.
about exchange rate, like
Yes.
the issues. Okay, cool. So we'll dive into that in a second and talk a bit more about that. But essentially, I don't think you really need to worry about enforcing that through the center of the network. Basically, the idea is that these sort of quotes, exchange rate quotes, would, while we're making this invoice or going through this process, right, you'd sort of get a quote and there's a time limit on that. Right, so it's like either this transaction makes it through within 1 minute, 5 minutes, whatever you set, or it doesn't, right? And this is the quote that you get. But we'll
Yes.
definitely.
yeah, so just like, in Lightning, you have atomic transactions. It either all goes through or none of it goes through. And during that RFQ process, the entity is basically providing a rate. Hey, I will, push out 1 Bitcoin if you push in, $67,000 to me. So there isn't, slippage concern where someone could deliver less than what was quoted. The HTLC will just fail in that situation in the same way that if, in a Lightning channel, someone, tries to shortchange an HTLC, people will just say, I'm going to fail the payment.
Yeah. Question. Yeah.
It sounds like you need the edge node if you want to receive a specific asset. But if you're open to receiving any of the assets, like if you wanted a US-based asset, do you need to be connected to the edge node?
So essentially, well, here's the idea. Like I could run a node where I have some channels, right, with people that are assets, right, Taproot assets, and I have some channels that are Satoshis, and then I can decide what I want to accept. But if you want to accept, like Zane there wants to transact in a euro-denominated asset, right, and he has to have a asset channel set up with someone. So essentially in Zane's scenario, he wants to be connected to an edge node. He can be connected with, have other nodes who have, the same asset in them, right? But if he wants to do that conversion, if he wants to be connected to the broader Lightning network, but doesn't want to have Satoshi channels himself, then he needs to be connected to an edge node. All right. Yeah, cool. All right. More questions? Okay, cool. Now,
And we'll get into some cool demos where, non-Taproot asset Lightning implementations can pay Taproot asset invoices. So that might kind of target what you're thinking about.
yeah, and when we do, when we get into doing Polar stuff, and I have some videos too where we can show sort of someone generating a Satoshi invoice but paying it with assets and vice versa too, which is fun. All right, so now let's really dive into edge nodes. So if you have any questions about this, now we're really going to get in depth with how that whole process works. All right, what is an edge node? All right, an edge node is a Taproot asset aware Lightning node that routes payments between Taproot assets channels and Bitcoin channels. Okay, we know that. All right, edge node is a service provider with multiple public Bitcoin channels, or at least one public Bitcoin channel to the Lightning Network, and unannounced Taproot asset channels with their clients or whomever they're doing business with on the Lightning Network. All right, what makes an edge node different to an ordinary routing node or Lightning service provider is the ability to route payments in different denominations over the Lightning Network. So hopefully all of this is, you got this, right? So now let's move along to our pretty picture. So once again, we're imagining Bob as our edge node service provider, or as he's running this edge node. Bob, you can see here on this graphic, has a couple of big Satoshi channels out to just the broader Lightning Network. Perhaps Bob is already a routing node or some sort of service provider on the Lightning Network. And then Bob decides that he also wants to be an edge node and provide that service as well. So again, I have some of these channels represented here in green to kind of visualize a US dollar stablecoin channel, and some of them in blue to envision a euro stablecoin. But of course, this could be whatever it is that Bob is interested in transacting in. But we'll go with these two examples. So Bob sets this up, and he then does lots of configuration in his litd config file, and allows, and maybe he sets up he would set up a price oracle, which we'll talk about shortly as well. And he says, hey, I'm going to accept channels that are denominated in this particular euro stablecoin, and I'm going to accept channels that are denominated in this US dollar stablecoin. And then I'm going to provide people with quotes for those particular assets versus Satoshis, right? In case they want to use me to, route out to the broader Lightning Network. All right, so let me first show you this picture, and then we'll come back to the RFQ process. But here, I guess I've changed scenarios now where Bob is no longer the edge node. But we can imagine we have an edge node, and then again, this is just a different visualization of the same graphic we were looking at earlier. So Alice can interact with Bob, and Bob can interact with Alice, all using this edge node provider. So let's go back here. All right, request for quote. RFQ is a mechanism that simplifies sending Taproot assets over Lightning channels. The request for quote contains a rate and an expiration time, which allows the sender to decide whether they want to complete the payment and craft a route to the intended recipient. So Alice wants to send a payment to Bob. Bob wants to receive Satoshis. Alice pings the edge node and says, hey, I want you to send some Satoshis to Bob, but please tell me how many assets you need me to send you to get you to send Satoshis to Bob, right? And this is that RFQ process. And then the edge node comes back and says, okay, I'm expecting you to send me 4 units of this asset in order to pay this Bolt 11 invoice from Bob, right? Or vice versa, they go exactly the other way around. And then Alice can say, hey, cool, I'll take that, or she can say, that's ridiculous, I reject that, and I'm gonna go do business elsewhere, right? But it's an accept or reject scenario. Question here? So can the edge node renege on it? I mean, go ahead, but hold on. Daniel's going to grab that one.
Yeah, just like in route construction today, it's essentially what the network is doing is it's signaling its intent to route things, right? You're getting channel updates. You're getting hopefully accurate, up-to-date fee structures. You never have a complete view of that might be out there. You're doing your best attempt. And so, the node it's possible that it can say, hey, I've changed my fee structure. There are times where that might be, what needs to happen for the health of the network. Hey, there was some drastic change, but in essence, what happens is that nodes are competing for this traffic, just in the same way that the core, of the graph, the LN graph, is competing for this. And so the most performant, highest uptime nodes that perform this service are going to be biased towards route construction, and so there's a route construction penalty for failing to perform that.
Cool. Yeah. Question? Hold on, Mike's coming your way.
There's a concept of a rate tick hint. I was wondering what that's used for. Is that to just see if we're even in the same ballpark in agreement on a rate?
Hold on. Rate tick hint. JHB.
Yeah, basically there are facilities in place like during the RFQ process to help the two parties, come to agreement on stuff. So yeah, that's part of some of the details there. We can talk afterwards. It's kind of like a real niche part of the process, but yeah.
Yep. Cool. All right, another question?
So on normal Lightning Network, you can know about the fee you'll get charged by just looking at the gossip protocol. So it's much more efficient to construct the route and prop few routes. But in this example, for RFQ, in order to get the cheapest code, do you have to talk to multiple edge nodes?
Okay, so this is all happening sort of on the edge of the network, right? And so this RFQ stuff is not gossiped, right, on the gossip protocol. And so Alice would have, on her node, perhaps she's, running a full node and she's got the whole network graph there, but she gets a quote from the edge node she's connected to. If she has channels with a number of different edge nodes, right, then she can sort of rate shop between those different edge nodes and go with the one that she likes.
Yeah, so the benefit to this is that you have like a highly competitive model. If you're kind of familiar with like ISP pricing, is that like typically ISPs establish monopolies on last mile routes, right? The copper or fiber to your home is something that, gets monopolized by municipalities a lot of times. And so the great thing is that if there is an edge node out there that, is just, let's just say, always charging 10% markup, then it's only a single Taproot asset channel away from like smashing that monopoly and providing competitive prices. And so we expect there to be really competitive behavior to address that need.
Yeah, cool. All right, question here?
With that competitive landscape, if I'm a node operator and I'm looking for potential edge nodes to connect to, is there a place I can shop rates, basically, see what they're advertising, or hit
If
their
you build
RFQs?
one, there is.
Tap rate coming soon.
Yeah, so there's, basically like Taproot Assets really pokes at like the market nerd in all of us. It's really going to, expand what we can build out there. Lots of people are kind of bouncing around like new novel ideas, and yeah, come talk to us afterwards.
Cool. All right, let's go and see. Here we go. I think, hold on, let me check. Okay, so here are some docs we want to read. We're definitely going to dive more into the RFQ stuff, but we're going to do that when we get to the demo portion, because we're going to look at actually the configuration settings that we use for this stuff. We're going to look at the demo price oracle that's in the repo and how that works, and then we're going to look at sort of an RFQ rate calculator with decimal display stuff to really dive into. If you're going to set up an edge node, here's the configuration you need, here's the type of price oracle you need to run, et cetera, et cetera. So, all right, any other questions before we dive into the demo portion of the workshop? And what time do we have? Wow, 2:04, we are spot on, excellent. All right, any more questions here before we get into the demo? No? Does anyone have Polar set up on their machine and ready to do this? We've got a couple of people. All right, awesome, cool. So, this is what we're going to do. We're going to run litd via Polar. We're going to talk about litd settings. We're going to go open asset channels. We're going to talk about edge node configurations. We're going to try sending some assets on Lightning, and that should be fun. Again, what you need to participate is a computer and Docker and Polar. All right, I'm going to go very briefly through the Polar setup. I think, did I put another, there we go. If you haven't set up Polar yet and you want to, you're definitely going to want to grab this link here so you can look at all the specific instructions that I have added here, because we're just going to go through it very, very briefly. All right, so you want to download the Polar app image. So I think people that are participating already have Polar installed. Is that accurate? No one that's currently installing Polar?
If you need help, just raise your hand. You have a question?
You're installing it?
First time, all these images on the public Wi-Fi take forever.
Oh, yeah. So he's running it for the first time, and Polar is busy pulling in Docker images on public Wi-Fi. So, okay, he'll be with us in a minute. Cool. All right, so you would download the app image, you make it executable. Again, I told you this is all of the various different commands I ran on my machine, installing Docker, and then you want to install Docker Compose.
I had a question. Can you run Polar without Docker?
No, Polar requires Docker.
Yeah, so just a brief overview of Polar. It's a GUI for instantiating Lightning Network daemon containers. So you can create a graph of channels and then say, hey, I want Taproot Assets running on Alice's node. I want Core Lightning running on Bob's node, et cetera. And then in the background, it's spinning up all these containers to say, okay, let me simulate someone's computer that's running that. So, yep.
Cool. Yeah, it's very highly recommended if you're going to play around with Lightning applications. I think it's like the best place to start before moving along to like testnet and testing there. Cool. So all the different instructions. If you're installing this on a Linux machine, make sure to get your permissions right. This is a common error that pops up when installing, when trying to run Polar on a Linux Ubuntu-based machine. It's just a permissions issue. It's a common one, so I linked to it there. You can see the instructions. Basically, you have to make sure you're in the right Docker group, and then, as always, turn it off and on again, and it should work. And then you can run that command to make sure you got your permissions right.
If you need access to these commands, check the issue in the TABConf event for this, and we'll post them there. Yeah.
Cool. All right. So now I think I'm going to close out of here and switch over to just playing with Polar. But what we're going to do is create a new network. So we're going to start up Polar. We're going to create a new network. We're going to add 1 Bitcoin Core node and 3 LitD nodes. So hold on a sec. I'm going to switch my mic setup. All right. Can everyone hear me? That'll work. Okay, cool. All right. I'm going to exit out of here, go over to Polar. We can all see that. Awesome. And let's create a Lightning network. So I click here. I'm going to give it a name. We're going to call it if I can spell, TABConf 2024. Again, what we're going to do is create 1 Bitcoin Core node, because you always need at least 1 Bitcoin node running so we can get this all recorded on the blockchain. Polar uses RegTest, so this is a network running only on your local machine, which is, I think, a great first stop for testing different applications. All right, so we're going to go, for simplicity here, just 1 Bitcoin Core node and then 3 LitD nodes here, and we're going to create this network. And I love this because it has this fabulous user interface, all this drag and drop stuff. It is very, very fun. So I'm just going to set this up here so it's nice and easy to visualize what's going on. And we'll get this set up. And again, in this scenario, we're going to have Bob acting as our edge node, and we're going to go look at all his settings and all of that stuff. But first things first, I've got this set up. Does anyone follow along? You got your 3 LitD nodes going? Cool, awesome. And we are going to push start. And if this is the first time you're doing this, then Polar's gonna go out and download some Docker images, and that might take a sec. But with me, I think, yep, it's already shows started because I've done this a couple of times already, so I already have the appropriate images on my machine. One thing I definitely recommend is to turn on auto mine. I just like to set it to 30 seconds. That makes it very simple because it's everything that's going on here, like when you open Lightning channels or when you fund these nodes, right? All this is on-chain transactions that's happening here. So you've got to have mining going on in the background. If you set it to auto mine, it just makes it nice and simple. All right, so let's start off by funding all of our nodes. And Polar, if you've not played with it before, I'll show you how this works. It's super cool. You just click on Alice's node, and then we have this pop up here, which shows us all the different info, right? The node type is terminal, so lit D. We have the version, the status, all of this good stuff, and then we can go over here to actions. I am going to fund this node. I'm gonna give her, is that 2 million sats, and we're gonna hit deposit. Watch here, this is fun. Watch the block height increase when I do this, and Polar will do that automatically for me.
And is it possible to increase the font size, like Control plus or something?
Let's see.
Maybe.
Control plus doesn't really work there. Let me try this. No. No.
No big deal. I'll look it up.
Okay. All right. Cool. So now we see the block height increased here because I think we had to do some mining to get some coins, and then we can send them to Alice. So I'll go do this again because we all need Satoshis, right, to interact with Bitcoin or with Lightning. So we're going to send Bob. Also, everyone gets 2 million Satoshis. Satoshis for everyone. All right, so Bob gets some, and then Carol's gonna get some too. There we go. Everyone gets Satoshis. Awesome. So now what we're going to do, hold on, let me check my notes. All right, so we've enabled auto mine. We've funded the litd nodes. Let's come back over here. Done through a pull-up. Oh, we're going to mint assets, right? So we're going to keep with our scenario where Alice is minting Alice bucks, and of course she can't open a Lightning channel to Bob that has Alice bucks in it until Alice bucks actually exist. So we're going to go over to actions, and we're going to come down here, and this button says mint assets, right? And we're going to mint type normal. You can also do collectibles, but we're not going to do that in today's workshop. And we are going to give it a name, Alice Bucks. Cool. And we'll do 1,000. That should be fine. This button here, if you can't read it, says finalize batch to mint assets immediately. One thing that's really cool is that you can prep a number of different type of assets to all be minted in the same batch, so the same on-chain transaction. So it's just adding more Merkle trees to our Merkle tree data structure to mint a whole bunch of assets at once. So super duper efficient. Give me just a sec here. I want to change one of my settings. Hold on. I'm going to do this. Hold on, just a moment. I just want to change one of my settings. Standby. Uh-oh, did my computer freeze? Just a moment. Yep, it did. Hold on.
Yeah, we'll work.
All right, do we have any questions while I am fixing my computer issue here?
The quote request from the exchange rate oracle.
Uh-huh.
Is that just a simple, they publish an exchange rate and you just apply the quantity to it? Or capable of calculating different exchange rates for different amounts.
Okay, one more time, please.
Yeah, so for the current implementation of the quotes, if you ask it, you know, I want Alice bucks versus Bitcoin, will it give you a different number if you say 10 Alice bucks versus Bitcoin versus a million Alice bucks worth of Bitcoin, or does it give the same exchange rate?
So the simple demo price oracle that we're gonna do is just giving the exchange rate, not necessarily based on the quantity. Certainly you could create that if you wanted to. You could say Alice is, a whale, she does a lot of, business, I'm gonna give her a discount, or you could set that up however you like. All right, give me just a moment here. Hold on.
Troubleshooting question. So I'm
Yeah.
trying to run Polar and set up matching what you're doing. I'm getting an error on missing TLS cert for each of the nodes.
Just a moment. All right, so what was that? Oh, you've got help. He's got help. Excellent. All right.
Hannah, can I ask you the question about the setting that you mentioned last, the batch setting? If you don't select that setting, does that mean that the mint can be modified instead of being finite?
The mint can be what?
Modified.
I'm not sure what you mean by modified. Can you give me a specific scenario?
Like, can you amend the amount on the mint at any point if you don't pick the setting of finalized batch?
Oh, fine. So while Hannah debugs her computer, what a batch is when you're composing a Taproot asset transaction, you can stuff in many different, different transactions, right? Okay, I'm going to mint Alice bucks. I'm going to transfer this. I'm going to do Y. You might send, you've already minted some assets and you want to say, hey, I'm going to send some to Alice. Oh, also I want to send some to Bob and Charlie, whatever. While you're doing that process of composing, this tree structure, that's called a batch. And when you finalize a batch, it's basically to say, okay, wrap everything up, stuff it into a Bitcoin transaction, and get ready to broadcast it. And so that's what that setting is doing, is to say, hey, I'm not going to add anything more to this transaction. Just wrap it up, stuff it into a Bitcoin transaction, and let's go. To answer what I think maybe your interest is to say, is it possible to have an asset that has multiple mints? Stable coins will come out and they'll say, hey, we're going to issue some new tokens because, we've had commercial bank money hit our bank account. And so how you do that in Taproot Assets is something called a group key, which is basically a way to, bundle a bunch of different type of mints together, all in a homogeneous, asset. So, okay, there was a mint event on, the 1st of the month and on the 15th, and what a group key does is basically say, Taproot asset, Damon, treat these all as the same asset. So, yeah. Yep.
Cool. All right, we're back. Thank you, Stad, for that question, for answering that. All right, so let us mint some Alice bucks. So we're going to go mint type normal. We're going to give it the name of Alice bucks, and we're minting just 1,000 for this example. You can do whatever you like for yours, but I'm going to go ahead and mint. We notice here that our block height has increased, again, because that was an on-chain transaction, right? We're committing to that in a Bitcoin transaction. All right, now that Alice has some Alice bucks, she can open a asset channel with Bob. So we're going to go over here and we're going to open. So we've clicked on Alice's node. So we've got that. Then we're going to go open channel and we're going to open an outgoing channel. And this makes it so easy. We can see the source is Alice, the destination is going to be Bob, and we can decide what asset we want to have in this channel, right? So we can use Bitcoin, sats, or we can use Alice bucks. Remembering that, of course, even when we open an asset channel, there are some Satoshis in there, which is needed for exchange and for online transactions. Okay, so we're gonna go with the full 1,000. All of Alice's Alice bucks are gonna go into this channel, and she's going to open it.
So if you have multiple Taproot assets that you want to connect to an edge node, right now
Okay, so the idea is you're asking, can you have one asset per channel or multiple assets per channel? Currently, we're looking at one asset per channel. Yeah. Cool.
Hannah, maybe try on the very bottom right, very, very bottom right of Polar. There's a darkness, very, 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 yeah, there you go.
Well,
there's also like
makes,
on the very bottom right, absolute bottom right, there's a dark, and it might,
do we like that
is
better
that more
or
legible?
worse? Yes?
Okay, all right, we
Okay.
like that.
Cool. All right, we'll keep that. All right, so now we can see we have this asset channel between Alice and Bob. Another cool Polar feature is we can click on that channel and see the capacity, right? So we can see that there are Satoshis in that channel that's necessary, and we can see that we have these assets in that channel, right? So it's just some basic default settings that Polar has. You know, obviously when you're opening channels, you can do all kinds of different things. Okay, so now Bob is going to open a regular Satoshi channel with Carol, right? So we clicked on Bob, we're gonna go to Actions, and we're going to go to Outgoing Channel. We're gonna open the channel. The destination is Carol. We can see here we don't have an option to add assets to that channel because Bob currently is not the owner of any Taproot assets. All right, so we're gonna say we're just gonna do, gonna play with the lights, cool. We're going to do 100,000, that sounds great. Okay, cool, and let's open that channel. Awesome, and then we can come here and see the balance of that channel. So now we've recreated the scenario where Bob is acting as our edge node, and let's try a couple of simple transactions before we get into some edge node demos. All right, so we've done that. Here is a video which I can show you this happening on the, just using the command line, which I think is fun. Polar makes this so quick and easy, but it's almost too quick and easy. I think it loses some of the fun, so I still like to do this on the command line. And I'll show you this little video of me and Leo at Lightning Labs are testing some of this stuff, and this is just what it looks like when you open an asset channel on the command line. And this is exactly what's happening when you use Polar too. It's just sort of abstracted away for you. So let's do this. So we're using TABCLI in this scenario. We have our usual flags. Oh, well, we use TABCLI to get our info on a particular asset, and we grab that asset ID. All this data is available too on Polar. Then here, you notice we use LitCLI, all our usual flags. We're using this command ln fun channel, and there you go. We have to note the amount and the assets that we're using, and that's what that looks like. So that went kind of fast, but this is all in the slide deck, and it's, of course, all of this is in the docs at docs.lightning.engineering, so you can go and look at what that command looks like. All right, so we did. Now we're gonna do an asset payment. So I think what Bob is going to do here, we wanna send Alice bucks from Alice to Bob. So Bob is going to create an invoice. So we sort of right click and create invoice. And Bob wants to receive Alice bucks. We have 1,000 Alice bucks in this channel, so Bob is gonna request 100 of them, and he's gonna create an invoice. Cool, and this looks, you know, like a normal invoice, and we can copy this, go back to Alice's node, click here, and pay that invoice, and we're just going to paste it in. We're going to be sending Alice bucks to Bob, and we're going to pay that invoice. All right, now because they have this asset channel with each other, this sort of RFQ process isn't really happening here, right? They can just, you know, Alice can decide whether or not she wants to pay that invoice. So that is fairly simple. Now, what we're gonna do before we demonstrate this edge node thing is we're gonna sort of balance out Bob and Carol's channel so we can use that for some examples here. So right now in this channel, everything is on Bob's side of the channel. So Alice is going to create an invoice. That I think should balance out the channel, if I remember correctly. So we're going to copy that, and we're going to go back to Bob's node. He's going to pay the invoice. We're going to paste that in, and we're going to pay, and ta-da. So see how it's like too easy. It's not fun anymore. But Bowler makes it very, very easy to play with this stuff. All right.
Any questions so far from folks?
Question here.
While we wait for the microphone, you can kind of see the color balance change there. It's a little subtle, but yeah.
Yeah.
So you made the invoice denominated in the asset. How many sats actually moved?
How many sats move in that transaction? I can't remember the exact number.
So
Right.
what we've done right now is we sent a Taproot asset from Alice to Bob, and then we've prepared equally balanced channel between Bob and Carol. But what we're about to do is go through Bob with that. So I think kind of that's what you're going to do next. If I understand correctly? Yeah.
I'm going to go through that, but his question is like, and I think JHB might have the answer there, but it's like, so there's how many Satoshis, right, are we exchanging when we're exchanging assets? And what's happening, I guess his question is, what's happening with the Satoshis in this channel as we're sending assets in this channel?
Yep, so there's a minimum amount of sats I think you need to move for any HTLC to be like valid. I want to say it's 354, something like that.
354? All right, thank you.
So there's ongoing work to like do an HTLC in the opposite direction, so you always net out to 0, but you do have to move some minimum amount of assets, of sats to have a valid HTLC.
So with 354 and the channels are defaulting to 100,000 sats, is that correct? Does that mean you're limited to 333 payments if you do them all in the same direction?
Yeah, so there's an issue on the GitHub right now where we call this like premature channel exhaustion, where the enhancement that's going to land like very soon is to say, let's just net this out so that it can be long-lived. So there's nothing that prevents it forces that to be exhausted very quickly. It's just a matter of saying, oh, okay, let's refund this amount and keep this channel going, because that's what both channel participants want.
Nice. I think if you look at the actual, if you did it in the CLI, the payment would show a different number of sats than actually moved.
Well, let's look at a video now where we can, we'll do that in a second. When we do this edge node one, we can have a look at, look what happens. I have videos of it happening in the CLI, so we can maybe have a look at that now. So we'll look at that, then we'll do a payment here where we go through Bob is the edge node, and then I really want to dive into the price oracle and the RFQ settings. So let's go here, asset payment, here we go. Here is an asset payment, and I'll see maybe if I can pause that when we get to the end here so we can look at that payment and exactly what it looks like on the command line. All right, so let's go ahead. We're showing the channel balance there first. Then we're using lit CLI to add an invoice, so we're creating an asset invoice here. I'm just showing what that command looks like, but on this video, I'm going to be paying an asset invoice. So we have to note the asset ID and the amount. Cool. Now to pay it, we again use lit CLI. We use this ln pay invoice command. I'm noting the outgoing channel, all right, and I'm noting the asset ID, and then I'm going to paste in the invoice that we are paying, which we'll see shortly. Cool. Awesome. That's the invoice. We're paying it. We're confirming payment. And it succeeds. Oh, did I not pause that? Let me see if I can just pause that for you at the right moment. Yeah. Okay, cool. So we can have a look at what's going on here in our route. This happened on testnet 3 between my testnet node and Leo's testnet node. We can see the Satoshi exchange that happened here. And then, because we're not using the RFQ process. So when we do an edge node demonstration, you'll see up here, you can see some of the RFQ information as well that went through. And this is all in the slide deck, so you can come back and look at this as well. Cool. So now we're going to try an edge node payment. So I think the way we're going to do this is Carol is going to generate, so we're going to come back to Polar. Carol is going to generate a regular Satoshi invoice. She's going to generate a Bolt 11 invoice. And Alice is going to pay it using assets, and Bob is going to function as the edge node. Now, if this all works just fine in Polar, it's going to look pretty boring, right? So Alice is going to create an invoice. I'm going to do a very small amount. Let's do 1,000 Satoshis. There we go. This is a regular Bolt 11 invoice. We're going to copy that. We're going to come back to Alice's node, and we're going to pay invoice. We're going to paste that in, but this time we're going to say, hey, we are paying this with Alice bucks. And we are going to pay invoice. Payment succeeded. Woo! All right, so that, say when you do it on Polar, like it's too easy, right? So let's go look at what that looks like when we do it on the command line. So we'll look at this one here. In this scenario, I think I was paying the asset invoice, and one of Leo's nodes was acting as the edge node, and one of his other nodes was receiving the sats payment. So this is from perspective in this scenario, sort of Alice paying that asset invoice. So let's have a look at that. All right. So I'm using lit CLI to make this payment. I'm using ln pay invoice. You can see all in bold there is our regular Bolt 11 invoice, but I'm specifying that I'm going to pay this using this particular asset that I minted. So yep, we're going to pay that. And succeeded. All right, so I'm pausing it there. And you can see this is a multi-hop payment. All right, so we have an amount in Satoshis. It seems a little low, but hold on. And here we can see this get quote for 645 asset units at this millisats per unit, blah, blah, blah. We're going to get into that in a minute. But you can see we went through this RFQ process when making this payment. Cool. So now, what time do we have? Cool, we still got some time. Let's dive into looking at edge node configuration. And then we'll look at price oracles, RFQ, number crunching, decimal display, all of that good stuff. All right, we saved the best for last. All right, so we're gonna go look at here on Polar. You can see how we can look at if you're going to play with this stuff on Polar, I'll show you how to change the settings, right? So these are just Docker images. So Jamal is the one that made Polar. He's not here at this workshop, unfortunately, but how he's doing this is when you start up this litd node, he's just passing in all the config on startup, right? So we can go and look at the config items. I believe it's advanced options, and then here we can look at it. Now, a lot of this stuff is it's sort of customized specifically to Polar. You see all this like name stuff there, right? So we won't dive into that, and I'm not going to go through all of this because it's hard to read here. But if you want to experiment with this stuff and you want to try it in Polar, this is where you would go to edit these settings to say make one node an edge node and try different edge node settings, etc. All right, so now we're going to come back here and look at this slide where these are just pulled out of Polar at the moment, these particular settings here. And we're not going to go in depth with all of them. We just want to note them. This stuff, again, it is specific to Polar. So if you're doing this on a litd node on a test network somewhere, I might want to do a little bit different stuff. But when you're running litd, right, you can see because of Polar, we're running in reg test. We're running this in integrated mode, which we recommend for playing with this stuff. We have some, settings that LND needs, right? Obviously, you need Taproot channels in order to be able to do this, et cetera, et cetera. Let's get to the RFQ stuff. So what Polar is doing here is just sort of a mock RFQ process, right? Not a very sophisticated one. We have this really fun setting here. So Taproot Assets, experimental RFQ price oracle, and then you have to add use mock price oracle service, promise not to use on mainnets, right? You have to add that to your settings, because if you do this on mainnets, right, you're gonna get wrecked, right? Don't do that. But this is very handy when you're just experimenting with this stuff on Polar or on some of your test nets.
What's a price oracle?
What is a price oracle? Great question. Okay, so let's go and look at, where's the pretty picture I'm looking for? Here we go. So in this scenario, Alice wants to send USD through this edge node, and then Bob wants to receive Satoshis. This edge node has to know what the current exchange rate is, or what exchange rate it's comfortable with, right? So how many USD do I need to receive to pay this, 10,000 Satoshi invoice that's, Bob wants, that Bob's looking for 10,000 Satoshis. How many USD stablecoins am I comfortable with receiving to send that out, right? So Bob needs to have, his node needs to, this edge node there needs to have some sort of way of knowing what's the current exchange rate, right? So I can show you what this looks like on a machine. Which node do I currently have this running on? Well, let me look at,
so there's like kind of software in place within Taproot Assets to say, listen, when you're just creating a toy payment flow like this, we'll stand up a very small server that replies back with some sort of exchange rate. But there's nothing. What we want to have happen is for people to express what their price preference is there, and so. This can be something where you poll, multiple different market sources. It could be you poll, your own backend. Hey, listen, I'm not going to, divest of my sats for, anything less than $100,000 or something like that.
Yeah.
So, yeah.
So this is the demo price oracle, which is in the Taproot Assets repo. So what I have done, what I've been experimenting with on some of my nodes is I have this price oracle, and this is written in Golang, and then I set this up, right? I sort of compile this on my machine, and then I run it as a systemd service, right? And then it's listening on its port, right? And then this is fairly simple, right? So we can come down here, and we'll dive into this in a minute. We can see where we would set. This is the number we're looking for, right? So this is, currently we're doing this in, I think it is asset units per BT.
Yeah, so it just recently changed, and this is kind of going to your question, is that it used to be called rate tick. I'm so glad we killed that term. It's really an asset rate. And so if you look at the comment right before it, it kind of gives you an example of, okay, what are the units here, and yeah.
Yeah, so we can look at, we're doing Taproot asset units per BTC, right? That's what this number is. We'll come back to this again and look exactly how we want to calculate this number. This price oracle is very, very simple, right? You just add an exchange rate in there. Now, if you're running this in production, more sophisticated, actually, you would add a couple of functions in here which says pings an API. Go talk to this exchange and get me the latest and greatest, the absolute latest exchange rate info, right? And then you can add whatever custom logic you want to here, right? So you could add whatever you'd like to this price oracle to do different rates in different scenarios, right? And so you can kind of do different rates here for like buy or selling assets. And up here, we also have a function, here we go, which is supported subject asset. So if a node pings you and says, hey, I want to sell 300, I don't know, silly bucks, and you're like, sorry, I'm not willing to take your silly bucks, right? You can decide what assets you're willing to support, right? So that's what you would want to do in this price oracle. And this is some examples here. You can decide what assets you're willing to support and take in, in exchange for Satoshis. And then you can add some logic to this function down here to decide what you want the exchange rate to be. And then you could add whatever you liked here into whatever different scenarios you could change and add whatever you want. So, bless you. Let's go and have a look at, again, in the repo, there is this doc, which if you're really going to dive into this stuff, I highly, highly recommend reading, right? And it explains decimal display and how all of this, the RFQ process and how these numbers are being crunched, right? So I believe Ollie and Roast Beef collaborated on this doc, and that really explains it for you, breaks down what exactly is happening. All right, so let's talk about decimal display. All right, finally, right? We've gotten there. All right, so the thing is that if Alice issues her stablecoin and it's Alice bucks, and in her first round of issuance, she wants to issue, let's keep it really simple, $1,000 worth of Alice bucks. Now, you might initially think, okay, well, she just mints 1,000 units of this to make, 1,000 Alice bucks. But then the question becomes, what if Bob wants to buy 50 cents worth of Alice bucks, right? How does Alice account for that, right? And especially when we're talking about on the Lightning Network, we can get some pretty small denominations, right? We can do sats, but then we can also do MSATs, right? Millisats, right? So the question is, how many units of your stablecoin or your asset in whatever scenario do you want to mint to then satisfy a, perhaps like how small of a transaction do you want to be able to do? Do you want someone to be able to send 1 Satoshi worth of your asset on the Lightning Network? So how many units do you need to equal $1? That math will give you a headache, right? I've read this doc a number of times, and it gave me quite a headache. I went and made this, and so we might add this calculator to the docs if some of y'all think this is helpful. We got one yes, they might want to use this. And this is a little calculator that I just made in, Google Calc, like spreadsheets, right? So you can go and add, all right, how many, what did I do? Thank you, okay. So you can go here, right? And I can say, all right, how many of my asset do I want to be equal to $1 US? What's my decimal display gonna be? What's the current price of Bitcoin? And it crunches all of these numbers for you. And it is this assets per BTC that is the final number, right? That is what your price oracle is going to return to your Taproot Assets node. So I believe that's here, like that's this final number that's gonna show up there. So we have questions on this, I imagine. Let's do all of the RFQ decimal display questions.
Yeah, so just for context, I don't think that like end users of Taproot Assets are really going to be interacting with this. A decimal display is most relevant for an asset issuer when they first are minting an asset. You basically are deciding how, what is the terminal resolution that I want to be expressed in this thing. And there's some, like computer science stuff of like floats are a pain in the ass, especially when you're working with, financial software. And so this, what needs to be done here is kind of like a once set and forget it, typically by an asset issuer, not something that you'll really need to think about a ton, but it is, relevant if folks want to ask questions about it or dig in.
Yeah, so this is very relevant if you're minting assets or running price oracles on your edge nodes, yes.
My question kind of is about the floats. So if we look here, MSATs per unit is 1.49.
Yes.
If we go back to the RFQ code, we're returning an integer right now.
Exactly,
And
yes.
so we can quickly run into problems where that's either going to round down or round up, and we're going to either way underpay or way overpay.
Which is why it was updated, yeah. But
Yeah. So internally, the Tap daemon uses integers everywhere for representing quantities. The only time where like there does get to be a rounding issue is when there's an MPP payment of an asset flow where, hey, these are going to get split up into certain shards, and there's going to be just some terminal amount there where an MPP shard is either going to go through or not go through. So there's nowhere in the daemon where an asset amount is represented by a float, because we hate floats in financial software.
Yeah, but that is also why we're using the Taproot assets per BTC in the data, the number that's actually getting communicated back to the Taproot asset node.
JHP,
Question
do you want
back
to
here.
say anything about it?
All right, hold on, JHB. 's
Not
gonna wave.
exactly. I mean, we had an initial version that had problems, and those problems are being fixed. There's like PRs up
Yep.
to adjust some of this stuff, so it's easier to think about. And
Yeah. Cool. Oh. And Ryan wants to say something too. Yeah.
Different question.
Like hypothetically, if I was scared of rounding errors for MSATs and stuff, is there any issue with having too much precision, with like erring towards a decimal display of 10, other than that just being inelegant?
Yeah, unfortunately, computers have like limited memory, and so there is a trade-off here where you can't just say, oh, I'm going to have infinite precision. Some of the docs discuss this. There are eye tests where we kind of chose, hey, okay, these are optimum values. If you'd like to really dig into that, I would recommend checking those out. There is a balance where you want enough precision so that when things are routing through the Lightning Network, that people aren't saying, hey, why is this happening? So
Yeah, and this is really, if you want to dig into the weeds on this, this is discussed in this doc here, pretty in depth. Yeah, with current recommendations. And we had a different question here. Yeah.
Yeah, it's related to the RFQ origination. So in the example of Alice pays Bob through the edge node, there was a line in the completed invoice that mentioned the exchange rate, the get quote, and then the specific rate between those two assets.
Right.
That Oracle data feed is being run, pulled in, and served by the edge node, correct? Where the edge node is pulling
the
in.
edge node is running the Oracle.
Yeah, it's basically like a toy demonstration to say, imagine there is some sort of price feed. That might be you going out and collecting a quote from Bitstamp or Bisq or RoboSats or your own order book. You might have traders that say, hey, don't sell for less than 75,000 and buy at 50,000.
Got it. So the order of execution is invoice requested, payment, quote requested for the exchange of the asset that is intended to pay, execution of that payment, given it's within the time lock.
Yep, exactly. So what happens when an asset recipient generates a Taproot asset invoice is they say, oh, okay, I'm going to generate an invoice. That means that I'm going to be routed through my edge node. Okay, do I have a recent quote that I can use? No. Okay, let me go talk to that edge node. Hey, I'm about to route through you. How many sats will you demand to be pushed into you to push X number of dollars to me? They come back, they say, okay, hold on a second, let me check my price oracle. Okay, the price oracle came back with 1,000. I'm going to charge a 1% spread on that. Okay, go back. I give that to the invoice, and then that's put in, and so it's all encapsulated.
Cool.
Got it. Thank you.
Awesome. All right. So
Do we want to talk about the graph problem of, hey, how can you do route construction to channels that aren't, or do you want to save that for later?
So you're talking about so let's say Alice is paying someone all the way out on the network, and she's using assets to pay someone else, right?
Yeah.
So if I understand it correctly, Alice has to go through that RFQ negotiation process with her edge node, but then she still constructs that route.
Yeah, so I'm not sure, this gentleman's name here, but essentially the observation or the root of your question was if there's an unannounced channel that's not in the graph, how do these nodes do route construction, right? And so the observation is that we might have up-to-date knowledge about the LN graph, but how we convey this kind of hidden last mile of addressing is by including local topology, local channel topology information within that invoice, right? And so the recipient who's generating that invoice says, hey, I am going to stuff some local topology here. You might know about the route to get to my house, but you don't know the route to go from my door, into my room, into my wallet. And so that, local topology or local graph information is stuffed into the invoice so the, payment originator can say, okay, there is this hidden channel here. I don't know where I didn't know where it was. Now I have that information and it's been conveyed through the Bolt 11 invoice, through this field called hop-ins.
Yeah, and this is true of like any unannounced channel. Yeah, thank you. All right, we have 10 more minutes, so I think we've concluded the bulk of what we wanted to cover today. Let me check my notes. Yep, we have gotten there. So let's go to questions. Is there anything that someone wanted to discuss that we did not get to today? No? Nope. Oh, here we go. There's a question.
Easy one. Is this live? If not, when?
Yes. Yes, this is absolutely live. There are wallets and issuers now that are issuing Taproot assets that you can use on the Lightning Network. So it's totally live.
It's running in production. I don't know. Maybe we don't. Yeah, come talk to us afterwards. People are running this in production. There's consumer-facing apps that run Taproot assets in the background. Kind of the state of the market right now is that two companies have bridged assets on top of Taproot assets. They're essentially, these companies' Tether holdings that have been reminted within Taproot assets. You can send and receive those, on mainnet today. So yeah, it's running in production.
Yep, awesome. It is. Question here. Hold on, Mike is coming for you.
So if I've got two channels between my node and your node, one which is denominated in Alice bucks and the other is denominated in Bitcoin, can I pay myself through you?
Could you do a circular payment through an edge? I mean, I imagine so. I don't know if that's currently built in. In theory, you could. I don't know why you would necessarily, I guess to do an exchange.
Yeah. So like, if I understand you correctly, you're saying, yes is the answer to your question.
Yeah. Theoretically, you absolutely could do that. Yeah. Cool. All right. Another question here in the front.
Sorry, I just feel like I'm hogging the mic. Currently, as I understand it, you can only add in your lit.conf file one RFQ service. Are there plans to support multiple?
Yeah, so we want there to be like as many RFQ options as possible, and that's how we have like a healthy, thick market around this. No, design constraints that say there only needs to be one. It's just a matter of getting code. If that's something that you want to do as a first-time project, we definitely, Taproot Assets is open source. The spec is, a BIP, and yeah, it's like very hackable protocol and daemon.
Cool. All right. Any other questions? Oh, JHB wants to say something.
Yeah, I was just going to say, like, if you wanted to make some more complicated RFQ service, I guess, at least with how things are set up right now, you want that complexity sort of in this other daemon or service that you're running to. So even if we keep the setting of like talk to exactly one other service, maybe that thing is going and, pulling feeds from multiple places, or like it's consulting 3 other services and doing some average or whatever. But ideally, that sort of complexity is outside of this code base for now.
Cool. All right, we'll call for one final question. Now, We're good?
One more.
One more?
Has to be one more.
Oh.
Got one back here.
We got one back there. All right.
Maybe you've addressed this, but how does asset discovery works for an edge node? Maybe I want to support as many assets as possible to make money, but
How does asset discovery work?
Yeah.
Okay, cool. So this is going back to the concept
beginning.
of universes, right? And
Do you want to just pull up Terminal live?
pull up term?
You know, where we have like the assets listed. I think it's like a terminal.lightning.engineering.
I forgot the R.
There you go.
Okay.
And then assets on the top right. Bada bing. You know, so there are Lightning Labs runs this, demonstration of a asset discovery service. There's also other. I think there's like maybe 3 or 4 other services that also, convey this information. So yeah.
Yeah, so this is called sort of universe, and it holds various different asset information, and people run public universes where you can gather asset data if you are interested.
Yeah, so kind of the state of the block space market is that there's all these people who are putting, data on chain to solve this like data availability problem, and you don't need to do that at all. You actually like kill your market if you try and do that. But Taproot Assets basically does this in a really hyper-efficient chain space way, but still has all the nice, UI elements and trust minimized.
Awesome. All right, I think we will go ahead and end there. I'll be hanging around for a while if anyone wants to have a chat about anything we've discussed, and you can find me and all of us if you're interested in building this and getting more information. Here are all various different places to do it. So thank you very much.